All right, good morning everyone. Welcome back to Historical Geology 1404. Today is your final exam review. Yay! Yeah, you made it. You've almost made it because you still have that final exam to get through. Yep. Huh? We do. Yes. Because you all are high school students, and I am your, for lack of a better term, designated babysitter for these 3 hours, which I do not like, but we've already covered this. You will be required to be here in class next Tuesday. No, the semester ends on Tuesday. Last day of class is on Tuesday, which means that, yeah, you will need to be here for the whole block on Tuesday. Nothing I can do about that. No wiggle room. Yeah. This is your last exam. Now, some information about this exam. It is cumulative. That means that it covers everything from lecture 1 to lecture 13.
Okay.
Huh? 13. Yeah. So be prepared for that. I want to say 20? I changed it, actually. I changed it since the last time I taught this class. So let me jump in.
So some of the lectures only have one question?
Oh, I'm not guaranteeing that every lecture will have questions represented here. I'm not telling you exactly what will be there. I'm just telling you that because it is cumulative, there is the potential for every lecture's content to be on here. Uh, 19 questions on this. Also, don't forget you do have a lab exam that you need to take as well that opened for you on Tuesday. How what? You redid your lab 3? Great. I'll go in and do another grading pass through whenever I have the time. All right, so some other information. 19 questions, usual suspects, short answer, multiple choice, true, false, ordering, matching. You know the drill by now. No textbook, no Google, no working with each other on it. Your notes. However powerful your notes are, that'll be your greatest ally. You can still turn in your notes. Y'all can still turn in notes. Like, it's fine. Yeah. Like scrap paper for writing on? Yeah, sure.
Notes 1 through 11, but I didn't bring anything, and I plan on
See, those are index cards. Let's try and find you some actual paper. That's scrap paper. You want to use the other side of that? I mean, sorry. Yeah. I should probably have some lined paper in here for occasions like this. Sweetheart, come on now. What is that? You're going to be snappy, then I'm going to have to wear this. What was I talking about? Oh, right, okay. Everything has to be turned in no later than midnight on Tuesday. Okay, you have 5 more days. I will be coming in first thing Wednesday morning, closing the class, and calculating final grades. I love the confidence, and I really want you to pass. I really want everybody to pass. I really want everyone to get an A. Each of you has that capability. Here's something that's... So yesterday was the deadline for me to turn in the latest grade report, which I did. So whatever your grade is right now is what the grade will look like on your grade report. If you don't like it, there's only one person that can change that. Huh? Yeah, it's you guys. So please take the time to work on the material. Yeah. Oh, 100%. Well, that grade report is gone. That's shipped off. Yeah. But your final grade is the next grade report I will give. And you absolutely have the ability to change that. Okay? Anything that you have that has a 0 on it, you go in and you just do it. Even if it's an exam you missed, do it. It's pretty late at this point. Yeah, I need that Shia LaBeouf meme out here. Just do it, right? Please. Yeah. Yeah. Even if you get 10 out of 60 on a lab, it's better than 0 out of 60. Just do it. Take the time. Jackson, you had a question? Because she's snappy this morning? Yeah, Medusa's right here. Yep. Yep. The other day when I was holding her, I held her the whole time. She never snapped at me once. I thought it was good progress, but I had her out here yesterday, and I've had her out here this morning, and she keeps snapping at me. So I have a safe hand that she can snap at if she wants, and one that I pick her up with. She doesn't hurt that much when she bites you, but I still don't want to get bit. It would be more inconvenient than anything. It wouldn't hurt that much, and I wouldn't bleed. It would just, I don't want to. Huh? Can I help you on the lab? So today is primarily to help you guys feel comfortable with the final exam. I'm happy to answer other questions like lab-related questions whenever there are not exam-related questions to address first. All right? So the time is now yours. You guys are well familiar with my exam reviews by now. You know it's dictated by you. Whenever there aren't any questions for the exam review, I'm going to have to assume that you are ready, and I'll just open the exam. Okay? So go ahead and take a minute, go through your notes, see if there's anything about the lectures we've had that you don't remember very well, or that you didn't understand very well. This is the great opportunity to talk about all of that, okay? Let's see. Also, I hope you all went in and watched that lecture I posted. Lectures 11 and 12. Very important to watch before you take that exam. Considering it only has 8 views, I'm going to go ahead and assume that not everyone has. Yeah. Yeah, that's tomorrow. Class movie night is tomorrow, in here, 6 o'clock. We're watching Jurassic Park. Extra credit, yep. All of an extra credit assignment you guys can do, just like we did in 1403. Online students, obviously, you're also welcome to come and watch that. Okay. Questions for the exam? Go. Hit me.
Will this exam be harder than the previous others we took?
This exam will be difficulty-wise on par with the other exams you've had. Shh. I won't say it's easy because it won't be easy for everyone. Huh? If you thought the other exams were easy, it's likely that you will think this one was as well. Different people latch on to different subjects, so where 1403 may have been difficult for you and 1404 is easy, someone else may have had a really good time enjoying rocks in 1403 and just not absolutely get fossils at all, right? So everyone's different. Yeah. What's what? A coastal reef complex. Good question. Are y'all familiar with what reefs are?
Yes.
Yeah. Yeah, the Great Barrier Reef is the largest reef in the world right now. You're right. A reef is essentially an ecosystem within which thousands of different organisms are coexisting and building a mega, I can't call it an organism, but it's like a mega structure that is also a living ecosystem, okay? So the corals build the structure, and the fish and the gastropods and the echinoderms and the anemones and all of these things live in and around it, okay? So it's this massive organically grown structure. A coastal reef complex is that, and they've been around for a very long time, as we learned here in Module 3. Huh? How are they made? Well, but when they first started, they were just made out of stromatolites, built up mounds of stromatolites. Then they transitioned from there to being different algal colonies, and sponges would build up on top of themselves. Nowadays, what we have is called coral reefs, and it's been like that since about the time of the dinosaurs is when they became mostly coral dominated. A little before then. But coral are colonial animals that grow a rigid mineral structure, like a skeleton around themselves. And it grows bigger and 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 bigger over time. So what you can end up with is coral reefs that are hundreds of miles long and up to like a mile tall, depending on where you are and what age we're talking about. The Guadalupe mountain range to the east of us, or to the west of us, okay, in New Mexico, is one giant fossilized coral reef. It was massive, right? We don't have any that big today. The Great Barrier Reef is the biggest one we have today, and it's pretty dang long. But it has not gotten as big yet as the one that would have fossilized into the Guadalupe mountain range. Did that answer your question? All right, great. Yeah.
Should I know what Pterozoic is?
A what?
Pterozoic?
Pterozoic.
Proterozoic?
Oh, the Proterozoic. Yeah, the Proterozoic is one of the eons of time. Okay. Do you have a geologic timescale pulled up?
Yes, sir.
Okay. Where is it? It should be to the far.
The very bottom, right?
Yeah, far. That's on the bottom.
It's one of the top bottom columns.
You asked him.
You mean left bottom columns?
Yeah, left.
Okay, it's the furthest left, which means that it's the largest distinction of time, an eon. Okay? Because we go big on the left to smallest on the right. Okay? So we have eons over here, then we have eras, then periods, then epochs. Proterozoic was the first eon. Well, not the first. You had the Hadean and then the Archean, right? And then the Proterozoic. But the Proterozoic led into the Age of Life, the Phanerozoic eon, as we call it. Okay? So then you separate that down into things like Mesozoic era, Cenozoic era, so on and so forth. So that's how you break down geologic time on that time scale. But that Proterozoic one is the one that was precursor to modern time, what we call modern time.
And then, like, the volcanic volatiles?
Yeah. Volatiles in volcanics, volatiles at all. Volatile is a term that we use to describe any material that causes another material to react, okay? Or a system to become unstable through a reaction. So in the case of volcanics, it's going to be things like water. What happens when you heat up water really fast. Yeah, you flash vaporize it and it turns into steam. That can cause an instant reaction. You ever seen a tree that got struck by lightning? What happens to it?
It looks like lightning kind of in it. It looks like it's all different.
It splits open. It cracks open like an egg. It gets ripped apart. Some of them explode. Do you know why that happens?
Because all the energy put into it.
Because all the energy goes into that water, and what happens to the water inside of that tree? Flash vaporizes, and all that steam inside the tree blasts it apart, rips it open. Okay? So clearly a very volatile situation there. You introduce water down into the mantle, and yeah, it's going to be a volatile because it's going to reduce the melting point of rock, for one thing, so you get that magma. But then also, it's going to build up pressure. It's going to be a pressure-building fluid, which is going to make the whole system volatile as it gets ready to explode. Okay? Any other questions? Yeah, sorry.
Why are fossils present only in sedimentary rocks?
Why are fossils present only in sedimentary rocks? What are the other two types of rock?
Igneous.
Igneous?
Metamorphic.
Metamorphic. Good. What's the problem with fossils being an igneous rock?
It has to be made out of magma.
Igneous rock is made from magma. Magma is melted rock. You melt a rock, the fossils don't survive. Okay? What's the problem with fossils being a metamorphic rock? How do you make metamorphic rock? I mean, sedimentary rocks have layers too.
It's like transformed.
Yes. Okay. So it is transformed, altered rock through heat and pressure. So it's possible that you could have some of the shapes of fossils left in metamorphic rock, very lightly metamorphosed rock. But it would be very, very changed. But possible. In most metamorphic rock, though, the heat and pressure that's changed it chemically has also changed it structurally, and anything left in your rock is most likely not going to survive, including fossils.
Okay.
Okay, so of our three types of rock, there's only one in which fossils can survive.
Another question.
Did you have another question?
No, that one.
Okay. What else?
Why is soft tissue? Why is the soft tissue? Why do we only see that hard?
Right, so the question is, why do only hard parts of organisms get fossilized?
Because the muscle and everything that can't take the decay of it.
Right. How many of you like a good steak? Yeah. You ever have a T-bone steak? No? With the bone in it? How delicious is that bone? Oh, the bone's the best part, honestly. You just crunch that sucker, swallow it right down, right? No, we don't do that. Why?
Because it's hard.
Yeah, it's hard. We can't digest it. We can't break it apart. It's harder for things to break harder stuff, right? That includes you and your teeth and nature with weathering and fossilization.
So, sir, like, if it's something that's not that hard that tries to break something that is hard, you think it will break it? It is pretty hard.
That can happen, but it needs to have an upper hand. For a softer thing to break a harder thing, it needs more. For example, a glacier. How hard is ice?
Pretty hard.
Right, but can you smash it with a rock? Yeah. Can you use a chunk of ice to smash a rock?
It depends on how thick the ice is.
Yeah, it depends on how big that is.
There you go. Glaciers pulverize rock. They rip rock apart. Why? Because you get a lot of ice. If you've got a rock and 100 feet of ice, yeah, that ice is going to absolutely obliterate your rock. So a softer thing can destroy a harder thing. It just needs to have another advantage, like more of itself, right? If I buried you in a ton of feathers, would you die? Yes, you would.
Really?
You get crushed by a ton of feathers, bro. It's softer than you individually, but you get a ton of it.
Like a literal ton.
No, a literal ton. A literal ton of feathers. You would get squished flat. Yeah.
I would like to ask. I would like to know more about
You don't either.
Ediacaran fauna.
Ediacaran fauna.
Ediacaran fauna.
The Ediacaran fauna are the first group of complex, soft-bodied organisms that we actually have evidence for in the fossil record. Okay? So prior to them, we only saw colonies of algae and the occasional sponges and what do you call those? Amoebas. Okay, things that look like amoebas floating around in the water. Okay, then all of a sudden, right before the Cambrian, we see what we are describing, what we are calling as the Ediacaran fauna, which are large concentrations of soft-bodied things. Think all the different types of slugs you can imagine, all of a sudden showing up in the fossil record. Now, the only reason we have the Ediacaran fauna is because of the extraordinarily well-preserved, fine-grained sediment that they were preserved in. These things could have lived all over the world for all we know, but we only have these one groups of fossils from Australia that they are present in. But we know that from there, after this point, life just exploded into the Cambrian. And then you had your trilobites, and you had your echinoderms, and all of these other things that started showing up. So that's what the Ediacaran fauna is. Think of it as the transition between your algal colonies and your complex organisms.
So, you said there's plenty of them, right?
No, there's not that many. So it's a small group of fossils, but it's very filled with fossils. So it's showing us that at least in this part of the world at that time, which the Ediacaran fauna was found in Australia, okay? At least in that part of the world, but likely in other parts of the world as well, there were lots and lots of different forms of life. But it is the only group of fossils that we have to support that. Maybe we'll find others in the future. We can only hope. He hasn't eaten his rat yet. I gave Diablo a rat on Saturday, and he still hasn't eaten it. No, it's alive. It's still just hanging out in there with him. I don't want to try taking Diablo out, because I might risk accidentally releasing the rat. If he still hasn't eaten his rat by tomorrow, then I'm going to capture it and release it, and assume that he's just not eating for the winter. Snakes will usually go into a state of torpor during the winter. So for about 3 months, they just won't move or eat anything. This may be his indicator to me that he's entered his state of torpor.
And you can still like hold him and stuff, but he doesn't have to eat.
He won't eat, and he won't be active. I try not to move him very much in torpor, because it's more or less a state. It's kind of like hibernation, right? Has anyone ever woken you up out of a deep sleep? Yeah. Right. It sucks, doesn't it? No one likes being woken up out of a deep sleep, so I try and leave him alone as much as I can.
He just sleeps for 3 months.
He doesn't sleep. He's in torpor. Torpor is basically a state of suspended metabolism. If you're a snake and you rely on the sun to warm you up, what do you do during winter when the sun is either lower in the sky and therefore not and therefore not present for as much time, or it's behind cloud cover, rain, snow, whatever? What do? Snakes have evolved the ability to go into torpor, where they basically just stay in their bed. They don't need to eat. They don't need to poop. They just kind of hang out ever so slowly, burning off the reserves of fat that they've built up, just like a bear in hibernation would. Mm-hmm. But you don't quite know that you're supposed to do that yet, do ya? Yeah. I fed her on Saturday too, but she ate it up right away.
Sir, could I get more information on the Sudbury impact?
The Sudbury impact occurred 1.85 billion years ago, I believe, up in Canada. It was a massive asteroid that crashed into the North American continent, which at that point was called Laurentia, not North America. It was combined with Greenland. Okay, and it drove, this asteroid dug so deeply into the Earth's crust that it actually exposed the mantle under the crust. And it chucked pieces of the crust up 800 kilometers across the planet. There are pieces of debris from that impact that we find out in the middle of Canada. Okay, pretty far, pretty massive impact. Probably responsible for at least a regional extinction in the life that was living in the area. But it's significant because it exposed the mantle and it dug a hole in the crust and allowed the mantle material to rise up closer to the Earth's surface before it recrystallized. It's gotten covered in sediment since then. But that's the closest the closest place we can get to mantle or near mantle rock. And so a whole bunch of mining companies have built up on top of the crater, and they drill down and they dig their pits to access that material that is near mantle in chemistry, because it is rich in metals that we have rarely at the surface but are more common deeper underground.
That's crazy though, how like even got this mantle.
I know. Big impact. Yeah, it was bigger than the one that killed the dinosaurs.
The Laurentia.
Laurentia, yeah.
Yeah, Laurentia.
What about it?
It's like a continent, right?
Yes, Laurentia was a continent. It's a continent that's popped up several times over Earth's history. Laurentia is what we call the landmass that was a combination of what is now North America and Greenland. So if you imagine North America and Greenland's landmass combined, that's what Laurentia would have been like throughout time.
And so that's pretty, that's almost one of the biggest continents then, if they're put together, or-
At one point in time, it was one of the larger continents. Obviously, we have larger ones now. But continents always have mass added to them. Okay? As they collide with each other, they are adding mass to themselves. Also, as sediment is deposited on top of them, they are adding mass to themselves. So our continents have generally only gotten bigger with time.
Yeah, they really have. Like, this is how it looks right now, right?
Yep. Yep. Whereas 4 billion years ago, it would have only been a few islands in
So
a
the one on the top right, sir, is the biggest one?
Eurasia. Yeah.
So Asia's pretty much got it all, huh?
Eurasia combined, yeah. Africa is rapidly joining that party, though. Once Africa finishes colliding with them, it is going to be the largest continent that we've had since Pangaea.
And so we're pretty small kind of too, right?
I mean, only comparatively speaking.
And so we're in that middle portion, of course, right?
Now we're on the left.
Yeah, the United States is over there on the left.
Oh, gosh.
Yeah, between Canada and Mexico.
like with the, what about with like the Atlantic Ocean and stuff, like, and then the Pacific Ocean, like, there'd be, of course, they're not connected to each other, right?
Atlantic and Pacific? No, not anymore. The nation of Panama, do you see where Mexico kind of tapers down to this tiny little narrow strip of land before it reaches South America?
Wait, that would be where,
Here. Mexico, Guatemala, Panama, right here. Okay? This is Panama. That tiny little strip of land wasn't always there. It's only developed recently. Yeah, it's grown up there recently as a result of tectonics as these two plates interact with each other. That wasn't there. So the Atlantic and the Pacific were able to mingle with each other through this strip of water between these continents. So warm water from the Pacific would go into the Atlantic. But since Panama got formed, the Atlantic has only gotten colder because it can't get any of that warm Pacific water. So it's gotten colder, which means that cold water circulates up here and turns into ice, which is why now we have an ice cap up here. This is one of the things that led to our most recent ice age. Yep.
It's just how the movement of everything is what like caused that to happen.
Tectonics. Isn't that the magic answer for my class? Hasn't tectonics been the magic answer for so many things in my class? Yes. Right. So much, come on now. So many things on our continent, on our planet, I should say, come down to tectonics. Right? It's part of what makes our world unique.
Hey, sir, so, and what else, what about with certain elements that we use, like carbon? What else, like calcium, right? Too?
Well, what about them?
Like, with carbon, it's like it can be within certain rocks, right?
Yes.
Because, yeah, that's what I recall too, from seeing certain rocks. I can't recall which specific rock it was, but I know carbon was involved in it.
Oh yeah, carbon is involved in a lot of compounds and a lot of bonds. Carbon dioxide is an extremely easy bond to make, very common in our atmosphere. Carbon bonds very easily with things in general. Life on Earth here requires carbon. Carbon more or less makes the backbone of organic molecules. The hydrogens, the oxygens, the phosphoruses, they bond to things, but carbon has to be present there in those organic compounds. Okay? We cannot, at this time, see how life could form without the presence of carbon. You'll go into science fiction, you'll watch an episode of Star Trek, and they'll say things like, silicon-based life form, right? What does that mean? That means that where carbon plays such a pivotal role in our life here, silicon would have done for that organism. Is that technically possible? I mean, sure, but only in an environment devoid of carbon. Otherwise, carbon would fill that slot. So if you somehow have a world without any carbon in it, then it is conceivably possible that silicon could fill that part. It takes more energy. And nature works along the paths that require the least amount of energy. So there would have to be like no carbon. Any other questions? Say that again? Carboniferous. Yeah. Have you watched lectures 11 and 12?
I mean, it's technically over the notes that you put in, right?
What do you mean?
Like, it's technically over the slides that you put, right?
That's a big mistake.
Oh.
Yeah. The slides are only some of the information. I give you way more information in the lectures. The slides are essentially my notes, okay? I mean, if I only talked about what was on the slides, I could go through a lecture in 20 minutes. But instead, my lectures are an hour or more long because of the additional things that I add to them, right? Always, always listen to the lectures. Don't rely on just looking at the slides. Otherwise, you're going to miss most of the information you need to know.
Okay, I did not know that, sir. My fault. I didn't know
Okay.
that before.
Well, I mean, it's been the thing.
Informed that to us,
Oh, yeah. Day 1 in 1403.
Oh, I might have not been paying attention.
Gotcha.
That's on me, sir.
Yeah. Always, always listen to the lectures. I hate the type of teaching where a teacher just reads off of the slides or just tells you a few pieces of information and then just reads you a textbook. That's the worst way to teach ever. Why hire an expert in a subject if they're just going to read, right? That doesn't make them an expert in the subject. That makes them capable of reading. I'm an expert in my subject, so I teach you the things that I know, not the things that a textbook says. Right? The textbook is supplemental to me, and so are the slides.
But it's at the same time, you don't depend on it, which is a good thing.
No, I don't.
Yeah, that's
Right. Yeah. So go back and watch that lecture, especially before you try taking the exam. There's a lot of really important information on that.
I got you.
Yeah.
I would still like to know more information on the Mesozoic.
That's also in that same lecture.
Okay, oh yeah, same. Oh, my fault.
Yep. What?
Actually, sir, the Paleogene.
The what?
Paleogene?
Paleogene. That's what we talked about on Tuesday. The
Mollusks and like Teleos fish.
Teleost, yeah. So the Paleogene was the time period immediately following the Mesozoic. So the dinosaurs have just died off. So have a lot of other species, leaving a lot of available living space, a lot of ecological niches available for other forms of life to spread in and develop in. Okay? So that's why we see mammals start to rise. Birds get bigger. Teleost fish take over the oceans because a lot of their competitors died off, right? So all of these things that we recognize in our modern world today start showing up at the beginning of the Paleogene.
You said you're gonna use Google for this?
Modern bivalves.
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 Yeah, that's where a lot of those show up as well. Because there was a big die-off in the oceans at the end of the Mesozoic, which led for a lot of not only things that live on land that we recognize, but the things in the ocean as well. Our clams, our oysters, scallops, etc. Who likes seafood? You don't like seafood? Not really? Seafood's great. Huh? Crab? Ah, that counts. That counts as seafood. So my grandparents used to live in Western Washington in a town called Sequim. Have you guys ever read Twilight? Okay, so Twilight takes place in a town called Forks, Washington. Sequim is about 45 minutes from there. I've been to Forks a bunch in my childhood because my yeah, it's gotten totally Twilight-ized over the years, right? I started going there before Twilight ever got published. And then after Twilight came out, the entire city of Forks changed, and now it's like Stephanie Meyer Central, okay? Like, there's a Twilight store on every corner, right? It brought them a lot of tourism, so they leaned into it, right? But in this town called Sequim, there's a place not far from there called the Dungeness Spit, where you can go out and fish and like walk along. It's a spit of land that goes pretty far out into the ocean. But Dungeness Bay is where the Dungeness crab is found. And we would throw some crab pots out there and then pull them back in with our friend's boat and have crab dinners every time I'd go visit. Just fresh crab straight out of the ocean that we caught ourselves. It was really fun.
I admit to it though.
I don't like shrimp.
Unlike you, talk to Abe.
You don't like shrimp. You like crab, but you don't like shrimp.
Wait, what?
Interesting.
I'm a very seafood boy.
No, I do love a good seafood boil. Once every 2 or 3 years, instead of having a normal traditional Christmas dinner, we'll have a seafood boil, where we just throw a bunch of fish and, or not fish, like shrimp and crab, potatoes, like we'll slice some oranges and lemons. We'll put, we'll cut some onions in half. We'll just throw a whole bunch of stuff in there, boil it up with some spices, drain it out, and then throw it on a table and just eat it like that. Oh, it's so good. That's a great question. All right, Juliet asks a very good question. She asked a question about identification for the exam. I do reserve the right to give you a picture and ask you to identify it. Now, this is a very important note, because how many of you tried taking exams in my class before and it said could not show you the picture? Take it on a computer that will let you see pictures. I do not know what pictures ECISD will let pass through. So I can't really do anything other than this, right? It's a toss-up. There's no one at ECISD I can say, hey, will this picture get through the firewall? No one will answer that question for me. So the best way to get past this is for you to use a non-ECISD computer.
So that brings that up, what if we don't have a computer that can do that?
You'll need, you can use your phone, or you can go to our Learning Resources Center here on campus. It's open until the end of the term, and they have computers that any student can use.
Okay. And so it's just like that time that
Yeah. Just look up the LRC hours. You're right. I think they're replacing the carpet at the LRC. The STEM Center over here, actually. You can use the STEM Center down the hall, guys. The STEM Center down the hall also has computers that you can use. Okay? It's just down here on the left, past my classrooms. Yeah, it's where all the tutors hang out. Yeah, it's where the tutors hang out, yeah.
Or the library.
The library is the LRC, but I think what Remy, you just pointed that out, right? Was it Remy or Leah? I can't remember. Okay. It's closed for renovations. They're replacing the carpet. All right, what else, friends? That we talk about that in that lecture you need to watch on YouTube. What else? The Eocene is something we talked about on Tuesday. What about the Eocene?
What was like during it? You know what I mean? Like what was the animals that were involved during that time?
They were getting bigger during the Eocene. The Eocene, we saw whales getting really big, start dominating in the oceans. We see a lot of the larger animals that we see on land now. Development of elephants started to get pretty big. Yeah, things just started getting bigger in general. Yeah.
I'll find everything on the video. Most likely, right?
Yeah, make sure you watch that. All right. You feel ready? You ready for this exam? Oh, she's got this. She knows she's got this. Everyone else at this table, any questions for me? Everyone's good? How about my middle table group? Yeah?
Yes, sir.
Yeah? Autumn? You good? Gentlemen, we feeling ready for this? You're all ready? All right. There we go. Did you say that you're raining?
No. I meant to say I'm good at
Greening?
I'm greening, yeah.
What does that mean?
I don't know. I accidentally said it.
See, this is what Jackson does. He says random stuff and hope that it'll catch on. No one will pay you a quarter every time they use it, though. That's the problem. You could say the most brilliant thing, and it'll go all over TikTok, and no one will know that you said it. Because everyone else will take credit for it. Yeah, you may. Aaliyah,
Right.
You ready?
I'm gonna take that from you.
Angie,
Oh.
yeah, Remy,
Don't make me a
Juliet.
teacher, Jackson.
All right, well, if everyone's ready for this, I will go ahead and open the exam. Now, you can start it now if you like, but we do have 2 hours left on our block here. Yes. So, this is what I'll do, okay? Because we have so much time, I want to make sure that this is a space that people can feel like they can take the exam right now if they're ready to. So I'm going to ask us to keep the volume very low. I'm going to ask us not to mess around anymore. Okay, let's cut any unnecessary conversations. Let's make this a good study space, even if you're not going to work on the exam, even if you're not going to work on my class. Use these next 2 hours as efficiently as you can to make your finals week as pleasant as it can be. Because your finals week is now. Because the semester ends on Tuesday, guys. So let's make the most of this time. And then you are going to have to be here on Tuesday. I hope by then you will have completed all the work. But if not, you will absolutely be able to. But you know, we can have a little more fun that day. We'll figure it out. Okay? We'll figure it out since you have to be here. But let's use this time right now as best as we can. Okay? So I'm going to go ahead and open the exam for you. All right.
Sorry, I thought you had a bid open.
A what?
I thought you had a bid open. I thought you already opened it.
No. No. I never open my exams until the reviews are over. Hold on just a second. Let me open my online class final. From this point forward, I will only answer logistical questions about the exam, not content-related questions. Okay? All right, it's open. If you're not going to work on it, please work on something else. I want to make sure everyone puts themselves in the best position to succeed in my class and all your other classes, okay? What's up, buddy? Oh, hold on, let me end the recording here.